All right, so now we're going to continue with an actual example using the t-distribution to find a confidence interval for the mean of the population. So first of all, let's review the facts that we must have a random variable that comes from a normally distributed population if the sample size isn't more than 30. The standard deviation of the sample must be able to be known or computed, and the population standard deviation is unknown this time. We need to find critical values, and then we'll compute the margin of error, which is done very much like the computation for the margin of error for sigma known, but this time we use t for a critical value and we use s in place of the standard deviation of the population, sigma. And then we compute our interval based upon the same thing, x bar plus or minus e. So here's our example. We have a sample of size 35, sample mean of 20, and sample standard deviation of 2. We want to find a 90% confidence interval for the true population mean. So I've written down all of my stats here, and what I have going on for me is that I have degrees of freedom, which is n minus 1, that would be 37 minus 1, which is 36, and then I have my alpha over 2 value, which is 0.1 divided by 2, which is 0.05, and then I want to go and I want to find my t. Now if I'm looking this up in the table, I'm going to try to look up at 36 degrees of freedom and 0.05 in one tail. So let's look at the table and we'll see what one of the problems, right? So 36 degrees of freedom. Oh, this one actually has a 36, so it's not a problem. So 36 degrees of freedom, and I need to know what my value is. So 0.05 in one tail. So 0.05 in one tail, this is the second to the last column. Notice the 0.1 in the two tails. Remember, that's the alpha value. So I'll scroll back down to 36. And so 36 in the second to the last one, there's my value. So this is approximately 1.688. And remember, I could use my inverse t and find out that same value as well. Now once I've found my values, the next thing that I want to do is I want to compute my interval. So I'm going to compute my margin of error. So my margin of error is going to be equal to that t value, 1.688, times my standard deviation, which in this case is 2, divided by the square root of the sample size, 37. And this value gives me 1.688 times 2, and then divided by the square root of 37. Now be careful that you don't put in 36 here, because this one is n, remember, it is the 37. I see a lot of students make that mistake. So my margin of error calculates out to be 0.55 and another 5011. And that's rounded to 6 decimals. You know, I like to put out 6 decimals. That way I have plenty if I ever need them again. Now my confidence interval is still created, x bar plus or minus this margin of error, just like it was before. But the margin of error is only going to change by the fact that my critical value is the t-distribution value, and my standard deviation is from the sample this time instead of the population, and that's why I have a critical value that's a t. So I have my my mean 20 plus or minus, and then that's my 0.5, and I'm going to go with 2 more decimals here, 0.55. And so I'll do 20 minus 0.55, and that's going to give me 19.5 approximately, and that'll be rounded to 1 more decimal than my original data. So 19.5 is less than mu, which is less than 20 point, and oops, not 5, that's 20 point and then 6. Okay, and that would be what I have for my my approximation. So we have the 95% or 90% confidence that the true population mean is somewhere between 19.5 and 20.6. Now our next example is going to actually have some data here. And this is more like a real-world example, right? You have data. So that means we actually have to calculate the mean and the standard deviation. It's not going to be handed to us on a silver platter. So we start by putting the data 2, 15, 17, so on and so forth, up through 50 into the calculator. So I entered it through the stat edit, entered into L1, and then I'm going to calculate my one variable statistics. And this is the time when in my classes I start letting people use their calculator to just find these values. So I'm going to tell my calculator the way, where I want to find this, and then I'm going to write down my mean. So my mean is 30, and I'm going to put a few more decimals like I always do. So 2, 3, 0, 7, 6, 9. Now I don't need anything more than tenths here, but I'm going to make computations out with 2, maybe 3 decimals so that I get more accuracy. Remember, we don't want too much round off. Now the standard deviation I want is not sigma. This is a sample. I don't have a population. You have to be smarter than your calculator here. So I need to write the one down that says S sub x. I don't want to see this on a test, by the way, students. I want to just see S there, but I'm going to write it there so you can see what it is supposed to be looking like on your calculator. So 12.859198 is what I'm seeing there. And then my n, and that's going to be the 13 values that I had for n. And so I've already shown my calculations over here, and this is the t that I'm going to go look up. So I'm going to go to my t table, and I'm going to look up 0.025 in the one tail, or 0.05 in the two tails. So this is the middle column, and I need 12 degrees of freedom. So middle column, 12 degrees of freedom. There it is. So the value I'm going to use is 2.179. Now once I get that value, I'm going to create my confidence interval. So my confidence interval starts with x bar plus or minus my e. And so now, once I have that, I'm going to go here and I'm going to say, okay, well I have, and x bar is 30.23, and then plus or minus, and then my e is 2.179, and then it's multiplied by sigma, 12.859, and then divided by, and then my sample size, square root of 13. Remember again, don't forget 13. Don't use 12, 13. And then I have to calculate that, so I'm going to get 30.23 plus or minus, and then 2.179 times 12.859, and then I'm going to divide that by the square root of 13, and that's going to give me 7 point, and then 7, 7, and this has 1 and 3 out here. So I'm going to round it to this position right here in order to add, subtract, and then I'll round appropriately. So I'm going to get that my mean is going to get stuck between 30.23 minus 7.77, which gives me 22.5, and 30.23 plus 7.77, oops, I hit a wrong key, 30.23 plus 7.77, and that's going to give me 38. So I'll mark it down as 38.0. And if we go back to our actual data there, we can see if we know anything about this, their ages. So I'm just going to put years out here. And what this says is that I feel that the true population mean is between 22 and a half and 38 years. So with 95% confidence, the true population mean should fall in the interval 22.5 to 38 years. All right, and so that wraps up how to find a confidence interval when that is approximately when that thing is approximately normally distributed, but the sample or the population standard deviation is unknown. And our next videos will be on the binomial.